Hello, my name is Tanaka from Gifu University, Japan. Today, I'm going to talk about how we could improve the explainability of machine learning for modeling site-specific crop yield response to fertilizer inputs by using the Moran's eigenvector maps. So first, that slide shows the backgrounds of our studies. We'd like to optimize the inputs of the fertilizers by using variable rate applications. But we need to know the site-specific crop yield response to inputs. This is the key analysis to optimize the prescription maps. And recent most studies propose to use the machine learning techniques to enhance the prediction performance by using the yield as response variables and the soil properties or the nitrogen seed inputs as covariates. But it sometimes fails to model the causal relationships. If we couldn't make this kind of the assessment of the relationships between the application rates and the yield, maybe the established prescription map isn't reliable. So in our studies, we set up the on-farm experimentations for assessing the wheat yield responses to fertilizers in Gifu, Japan. And we make the two models by using the spatial surrogate covariates. So one of them is to use the coordinates as covariates. So yield can be explained by X and Y coordinates, and also fertilizer rate is used as covariates. And another model is using the Moran's eigenvector maps. So this Moran eigenvector maps, so-called MEMS, is generally used as linear models for ecological studies. But we apply this method to our on-farm experimentations data analysis. And this MEMS can be obtained after the diagonalizations of the spatial weighting matrix, and which is also calculated from the geographical coordinates. So we have the n-1 and MEMS, and here I'm showing an example of the MEMS 1 to 5, and there are much more MEMS actually. And so this is a kind of the mimic of the soil spatial availability of the soil properties. And we use the MEMS 1 to 10 as a covariate, and also fertilizer application rate is used as a covariate as well. And we established the random forest regressions to model the relationships between the fertilizer inputs and the crop yield. And we conducted the sensitivity analysis to understand the crop yield response to inputs. And this is the result of the sensitivity analysis for the basic fertilizer application rates. So left side is the coordinate-based model, and the right side is the MEMS-based model. As shown in these figures, coordinates-based model shows that very strange relationships between the inputs and the simulated yield. So sometimes the yield could be reduced along with the increasing basic fertilizer rates. On the other hand, MEMS-based model shows very compatible with the agronomic analogies. So the yield can be rapidly increased in the lower basic fertilizer rates, but it reaches the plateau if we increase the rate of the fertilizer rates. So from this result, we can say that the coordinates maybe is not a good spatial surrogate covariates to model the relationships between the inputs and the yield, but the MEMS can be a candidate for modeling. So that's all my presentations. If you have any questions, I hope you can send me an email or on Twitter. Thank you.